Welcome to an in-depth exploration of Rajasthan's physical geography. Today, we are taking a closer look at the remarkable elevation and climate patterns that define the state's four modern topographic divisions. Let's dive in. To truly understand Rajasthan's landscape, we must look at how our geographic classification has evolved. Back in 1967, Professor V.C. Mishra proposed a human-centric, seven-part regional model. Over time, however, geography shifted toward a definitive four-part physical framework based strictly on relief features and climate. We now categorize the state into the northwestern desert, the Aravalli Range, the eastern alluvial plains, and the southern Hadoti or Hadoti Plateau. Let's break down the macro synthesis of these four main divisions. First, the northwestern desert is the largest, spanning over 61% of the state's area and holding 40% of its population across 12 districts. It originated from the ancient Tethys Sea and features sandy soil with an arid to semi-arid climate. Second, the ancient Aravalli Range accounts for 9% of the area and 10% of the population, stretching across 13 districts. This Precambrian folded mountain zone is dominated by forest soils and a subhumid climate. Third, the eastern plains make up 23% of the land but house a massive 39% of the population due to fertile river sediments, alluvial soil, and a humid climate. Finally, the Hadoti Plateau covers nearly 7% of the area with 11% of the population. Born from Cretaceous basalt lava, its fertile black cotton soil experiences a very humid climate zone. In Rajasthan, rainfall completely dictates the topology. This is best visualized by the Isohyet divider diagram. The 50 cm Isohyet line acts like a climatic wall running right along the Aravalli Range, physically protecting the eastern plains from desertification. Moving further west into the desert, the 25 cm Isohyet line dictates the transition where the harsh, sand dune heavy arid desert gives way to the semi-arid steppes, also known as the Bangar region. Let's zoom into the northwestern Thar Desert. Emerging from the ancient Tethys Sea during the Tertiary and Pleistocene periods, it covers a staggering 61.11% of the state's area. What makes this desert truly remarkable is its scale. It covers 12 distinct districts and houses an incredibly high population density for an arid environment, accounting for 40% of the state's residents. As we mentioned, the 25 cm Isohyet splits this region into the true arid desert, which is a mix of rocky hamada and active dunes, and the transitional semi-arid Bangar steppe zone. The morphology of the true arid desert is defined by its sand dunes. First, we have the crescent-shaped basins, which are highly dynamic and the most environmentally destructive. Transverse dunes form at perpendicular right angles to prevailing winds, while longitudinal or linear dunes run parallel to them. Parabolic dunes are hairpin-shaped and open opposite to the wind. A seef is a specialized basin with one extended arm caused by shifting wind patterns. Finally, star-shaped and shrub coppice dunes develop multi-armed shapes from irregular winds or form anchored around desert vegetation. Moving east into the semi-arid Bangar region, we find four highly distinct functional zones. In the far north lies the Ghaggar Basin, locally called Nali or Path, where highly fertile loamy soil creates an ideal zone for wheat and cotton. Below that is the Shekhawati inland drainage, characterized by ancient, sustainable water harvesting infrastructure like raw wells called Johads, monsoon, sar, ponds, and bead, grazing lands. Next is the Nagauri upland, famous for major saline lakes and the notorious hump belt, or Banka Patti, where high groundwater fluoride levels cause severe fluorosis. Finally, the southern Luni Basin extends through Pali, Jodhpur, and Barmer, defined by the saline Nehad Run and highly specialized halophyte plant ecosystems. The Thar Desert holds incredible geological anomalies hidden beneath its sands. Most famous is the Lathi series, a 60-kilometer-long underground water belt beneath Jaisalmer that magically sustains lush local savan grass ecosystems. Nearby, the Akul Wood Fossil Park preserves ancient wood fossils dating back 180 million years to the Jurassic era. To survive here historically, the Paliwal Brahmins engineered Plier and Khadan lakes, temporary surface depressions used for brilliant moisture retention agriculture. Now let's ascend the structural spine of Rajasthan, the Aravalli Range. Composed of Delhi supergroup rocks from the Precambrian period, this is the oldest folded, residual mountain range in the entire world. It acts as a grand water divide model. Rivers on the west flow toward the Arabian Sea via the Luni system, while rivers on the east flow to the Bay of Bengal via the Banas and Chambal systems. Stretching 692 kilometers in total, with 80% of its length tightly packed within Rajasthan, it forms a literal physical barrier blocking the eastward expansion of the Thar Desert. Culturally and economically, it is a vital treasure trove of metallic minerals and an ancient sanctuary for indigenous tribes like the Bhil, Meena, and Garasia. Looking closer at its topography, the Aravalli Range experiences a dramatic south to north elevation drop. It is tallest and most contiguous in the south, peaking at the formidable Guru Shikhar in Siroi at 1,722 meters, historically revered as the Peak of Saints. Moving north into the central Merwara region near Ajmer, the range loses elevation and fractures, marked by lower peaks like Todgad and Taragad. Finally, it tapers off into isolated northern peaks like Raghunathugad in Sikar at 1,055 meters. Navigating this rugged spine requires crossing its legendary plateaus and passes, known locally as Nals. The highest elevated block is the Hadoti Plateau at 1,360 meters, sitting near the Abu Block, which is a massive dome-shaped batholith structure. Further along, the Bhort Plateau forms a strategic high bridge between Kumbhalgad and Gogana. The Nals, or narrow transport corridors, cut directly through these imposing mountain walls. Key passes like Debar, Fulwari, Hathiguda, Desuri, and Ba have played a massive historic role, dictating all trade, military, and human movement between the disparate kingdoms of Mewar and Marwar. Descending east from the mountains brings us into the eastern plains, a region of immense agricultural abundance. Covering 23% of the state's area but supporting a staggering 39% of its population across 10 districts, this region was formed during the Pleistocene period by rich river sediments. In the south, the Mahi Plains, also known as Kanthal or Chappan, feature rich red loamy soil perfectly suited for hybrid maize and rice cultivation. Moving north, the Banas Banganga Plains take over. Specifically, the fertile Banganga Plains host the highest population density in the entire state due to their exceptional alluvial soil fertility. However, the eastern region isn't entirely uniform. Along the eastern border lies a geologically violent landscape known locally as the Bihad or Dam. These are the notorious Chambal badlands. Unlike the flat alluvial deposits of the Banas Basin, the Chambal River's rapid water flow and extreme gully erosion have literally chewed the landscape into near impassable ravines. This unique, harsh microgeography is famous historically for its rugged, defensive, and isolated nature. Finally, we arrive in the southeast corner, the Hadoti Plateau. Averaging 500 meters in height, it covers 6.89% of the state and holds 11% of the population. Geologically, it was formed from basalt lava rocks during the Cretaceous period and is sliced by a massive structural anomaly called the Great Boundary Fault. The region is split into two primary structural divisions, the Deccan Lava Plateau, which contains the Malav and Upar Mal tracts, and the towering Vindhyan Scarpland, which is world famous for premium building materials like sandstone, limestone, and the iconic Kota stone. The Hadoti Plateau stands out for its unique subfeatures and exceptional ecological wealth. Geographically, it boasts the striking crescent-shaped hills of Bundi and Mukundra, alongside the Shahbad upland in Baran, which homes the spectacular Ramgarh meteorite crater and the indigenous Saharia tribe. Driven by highly fertile, light black cotton soil, this plateau generates immense agricultural productivity, leading the state in cotton, local spices, and soybean yields. Furthermore, the abundant surface water from the Chambal drainage system supports incredibly rich aquatic biodiversity, acting as a critical primary habitat for rare alligators and the endangered Gangetic dolphin. From harsh sand dunes to ancient peaks and fertile river plains, Rajasthan's physical geography is truly a land of masterclass transition.